at question 6 on the same paper from 2023, and sine qx is f of x, and this is this. So if we look at this graph, this is a sine graph, it's classic. This is pi, or 180 if we weren't doing radians, and this is 2 pi. So if we needed to get this in terms of m and q, we would say that 4m equals 2q, 2 pi over q. And that gives us a kind of overview of where that's happening. So yeah, that makes perfect sense. So find an expression of m in terms of q. Okay. Now, on the axis above, sketch the graph of g. Now g is 3, so that means that it'll go as far as here and as low down as there. And then it's 2/3 qx. So if it's 2, 3, that means we're actually stretching it by the reciprocal. So we're stretching it 1.5 times. So that's why we've got it up to 6 there. So that means that every time we go up, we need to go along to this point, because that's going to be the highest point, because that's 1.5 m. So that's going to be the highest point. And then this is going to be the point where it goes through 0 again. And then 4.5 is going to be the point where it hits -3. And then 6 is going to be the point. So essentially what it's saying is stretch it by 1.5 and make it go all the way to 3. And that is what we're going to do. So that is gx. There wasn't a lot of writing for that, which is quite fun. But this one, I reckon there'll be a bit. So answer all the questions in the answer booklet provided. Unfortunately, I don't have one. So find the value of the y-intercept. So what we've got is h of x is 2x plus 3. Okay, lovely. Now, if we know that that hits there. And so the y-intercept is when x equals 0. So if we say that the y-intercept 2x e to the 0 plus 3. Now e to the 0, like anything to the 0, is 1. But then that's 0 as well. So that means this bit is cancelled out, plus 3. So the point where this slightly odd graph goes through the y-axis is going to be at 0, 3. So that's the idea there. Now find h dash x. So find the derivative of this. So if we've got hx equals 2x x plus 3, we're going to have to use the product rule because the 2x is what's-itting the ex, it's timesing the ex. So I'm just going to look up the product rule, and the product rule looks like this. So product rule is that if we've got an fx times a gx, you get f dash x plus, times gx. This is not beautifully written. Plus, and that's going to be g of x times f of x. Right, so let's make 2x f of x. Oh, let's just make it u. So u equals 2x, v equals ex, and that means u dash equals 2 and v dash equals ex. Now we just put it together in this way. I really prefer u's and v's. So that would be 2, let's make that the fx then. So that would be 2 gx, which is ex, plus, and that's EX, which is the same, so it's 2x EX. And that is the answer to that one. So you would get the 2x EX, so 2EX to the power x rather, plus 2x EX. Okay, right, hence find the coordinates of A. So A would be when they equal 0. So if this equals 0, 0 equals 2EX, only because it's when the gradient's 0, 2EX plus 2x EX. So what can we do with this to make it work? So I suppose we could take 2EX out of both of them. So 0 equals 2EX, and that would be 1 plus x. So we know that the easy one is that when x is minus 1, so if 0 equals 1 plus x, when x equals minus 1, and that also makes sense there, doesn't it? So we can find out that minus 1 is the first bit. Then we're going to have to put that x equals minus 1. Now we've actually got to put it back into the original thing, which is this one. So 2x EX plus 3. So if we put that back in, so 2x EX plus 3, and we're going to put in the minus 1. So it goes 2 to the minus 1, e to the minus 1 plus 3, and that gives us minus 2 over e plus 3, and that's our other little, let's make that e, and that's our other coordinate. Right, now we've got to show that h derived twice equals this. So we've already got this one here. This is our second derivative. So now our second derivative equals 2EX plus 2x EX. Now we've got to use the product rule again. And we've got the product rule here, but I hate what I just did. So that's u dash v plus v dash u. So now we know for this one, we're just going to keep, so for h, we're going to keep this one the same, 2ex, because e to the x goes to itself. But this one, we're going to name 2x is u. So u dash equals 2, v equals e to the x, and v dash equals e to the x. So this is going to be plus u dash 2 v ex plus v dash ex, I'm just going to leave that there, 2x. So now we've got a ridiculous amount of EXs and 2Xs and 2s. So now let's see what we can take out of this to prove this is correct. So we're definitely going to have a 2EX on the outside. Oh no, it looks like we need to have an EX on the outside. Oh, actually, so let's make that 2EX plus 2EX, it's 4EX, plus 2XEX. And then we're taking the EX out, so that's 4 plus 2x. Well, it's the other way around from that, but that's exactly the same thing as that. So what is find the values for x which the graph of h is concave up. And so that means that either ex has to be greater than 0, e to the x is greater than 0, or 4 plus 2x is greater than 0. So in the case of the latter, that means that 4 is greater than or equal to 2, or just 4 is greater than 2x. So if we divide through by that, so that would be 4 plus 2x is greater than 0. So taking that away, that's minus 2x, I apologise. So 4 over minus 2 is greater than x, so x is smaller than minus 2. And that solves that one. Now,